In this topic, we are going to see about the basic operational concepts. So, in the last class, we discussed about the various functional units of computer. That means what are all the units which are all present in the computer. Like for a human being, head, hand, leg, like the different units. For hand is for eating and doing any work activities. Leg is for walking, brain is for like that only we studied everything. So like that only we are now going to see about the basic operational concepts of a computer. So what the computer is doing, what is the basic operational concept, what is the basic operation of the computer, and what the role it is doing by the computer. Yes, first we going about basic function of computer. What is the basic function of the computer? What is computer doing? Suppose you said, sir, we are giving the data to the computer, it perform the task. For example, addition or subtraction, or sometimes we are giving any input to it, will perform the action and give us back the output. That's only computer doing. Here we are giving to execute the given task as per the appropriate program. In the program, what are the tasks we should give? We can give and execute the task, and then the program consists of list of instructions stored in the memory. Suppose if you are giving a task, means the computer will work out the task and give back you the answer as per the program what you are asked. Like that, the program, what the program contains, the program contains list of instructions. Every program have list of instructions. The instructions only executed, that is being carried out, and then answer will be obtained. The everything will be stored in the memory, that only the memory having the storing capacity. So this is a big picture, as like a picture we saw in the basic functional units. In this we have memory in this top of the picture, because memory is used to store the data which is being carried out in the operation. So here we are seeing MAR, PCIR. What is those types of, sir, you can ask. Nothing but MAR means memory address register, PC means program counter, IR means instruction register. Likewise here, what is MDR? In this MDR means memory data register. This is all the set of register R0, R1 up to R of n minus 1 based upon the application or the program. The registers will be used. What are the amount of data needed, we can use the register, because registers are used to store the values and data. Here what is we are using? Timing and control unit. What is mean by timing and control unit? Timing means, as I said earlier, in this every actions, timing actions will be takes place. So what is the timing action means? Clock signal or clock pulse. For every action, the time clock pulse or climb clock signal will be handled. At that time only every action will be carried out. So likewise only here, timing and control. So because every action there will be a timing and control also, we are having a control, because sometimes the timing action, these type of actions will be carried out. A control should be needed when to start, stop, or initiate, like that. So timing and control unit. At last we are seeing arithmetical and logical unit, as we said already earlier in the function unit. So these are all the different things we are using here. Let we see the things one by one. This is also important big question you should study for your examination. So as we said, register are first and standalone storage locations that hold the data temporarily. As I said earlier, register is stored only for temporary purpose. So multiple registers are needed. The multiple registers means here R0 to Rn minus 1 depends upon the value n, the amount of registers will be needed. So it will hold the data temporarily. Multiple registers are needed to facilitate the operation of CPU. So some of the registers are, two registers are there. First one is MAR, memory address register, and another one is MDR, memory data register. So to handle the data transfer between the main memory and processor, these type of registers are used, because as I said earlier, memory address register will store, the registers will have the memory address. That means what are all the address locations in the memory that should be needed, the address values are stored in the memory address register. So likewise, what are all the data needed for the operation will stored in memory data register. Two registers are there. Here one MAR, MDR. Here see, to the memory, suppose if any data coming, we have to store in address location value, because everyone is stored in the some corresponding address location. So at that time we are, what we are doing is we are getting the address value from the MAR register. Suppose two data are come, we need two location, because in a register all memory locations will need a address value. Suppose first one data is coming, we need a Address means suppose from MAR we are using 1000 as an address value, you store the number. Another data coming means we need another location. So from MAR we get another location. Is only unidirectional because we are just getting the address value only from MAR. No need to return back. But here see MDR, data register, the data can be come inside and also go outside because input data 5 and 7 input values will come inside the memory, and the answer 12 means addition value also go outside from the memory. So it is a bidirectional. Likewise the timing and control is also bidirectional because time will come, the time for clock cycle, and also control will be changed from here and there. So only it is also bidirectional. So this direction will arrow will place the corresponding sequence. So we already said memory address register will what the operation memory data, what the operation performed by that. Likewise instruction register is nothing but the register will have called the instruction that is being executed. What is the instruction? Suppose a program can have 10 instructions. Suppose seventh instruction being executed means the instruction register will have the seventh register at that time. After that instruction passed, then it will point out the next instruction, 8, 9, 10, so on. Program counter is nothing but points to the next instruction that is to be fetched from the memory. It is pointing to the next person. Suppose we are going into a place, 10 members are there means you can enter in the place. After that the corresponding security or person will point out the next person. He may alert the corresponding person to go inside to the path. Like that only it also count the number of instruction which is coming from the memory. Suppose you are going into a temple or airport, some other public places, a place is being kept, the person will go inside through the place. So how many persons entered you can finally find out through the help of the counter. That only here the program counter counts the number of instruction and also find the next instruction to be fetched from the memory. Here the program counter, what's the role of program counter? The contents from the memory address register of PC transferred to the memory address register. From the PC, the instruction transferred to memory address. From what the memory address it is address bus. So it gives a corresponding memory location and issues a read and write RDMA read and write control signals. So reads the instruction present in the memory loaded into MDR. So from the memory data address register, the data can be read to the memory and also will place in the instruction register. Contents will be transferred from MDR to IR. What the instruction? Suppose 10 instruction, after loading the 10 instruction, which instruction to be executed, 5th or 6th, 7th maybe. So corresponding registers will be transferred from MDR to IR. So the instruction represent in the instruction register will be decoded because the instruction register, what the instruction is present in the instruction register will be executed, that is decoded by the processor and understand the operation. So increments the contents of program counter one by one because one instruction completed means next instruction will be incremented by from the program counter, so that only the next instruction will be carried out. The data required for the operation is available in the register, it performs the operation. The data present in the memory following the sequence is performed. This cycle is completely returned back again and again. So as I said, from MAR, the address bus is used. The address bus carry the address signal. Select the memory location where the signal should be given. The value of the address of the data. Here MDR means here the database because the database can be directly routed to ALU and place the register and operation can be performed as it is a bidirectional. So result of the operation can be directly towards the output device, memory or register. So normal execution can be interrupted by some time due to the unwanted interruption signals like that. So here what we are giving, suppose you are giving, I say one example, you are going to add 5 and 7 means you will give the 5 value from the MDR to memory. So after getting the value of 5 from the MAR, it will find out a location to store the value of 5. After storing the value, it will get the 7 from the MDR. Then again it gets a corresponding address for the entered data. It store the value. After the addition takes place, 5 and 7 is equal to 12. The 12 value return back to the MDR as it is a bidirectional. From the memory, the address is transferred to the output. Here in these actions are controlled by timing. For one timing, one action will takes place. For fetching instruction, it may take amount of seconds, and also adding takes some amount of seconds, and getting the output also takes some amount of seconds. For every seconds, there will be a control in there to stop and start like that. it will be the carried out the operations and produce the results. So this is a normal operation, basic operation of computer. As you said already, I explained what is mean by interrupt, because sometimes interrupt will be occur. Interrupt means nothing. Suppose smoothly an action is going on, sometime action will be stopped. Suppose the class is smoothly going on by the professor in your classroom, means suppose a attender or a student entering the class may come in, sir, like that means the professor will divert from the class, and interrupt means a stoppage happened. This is known as interrupt. The interrupt is a request from the IO device, because sometimes from the input device some actions will be needed, so it may ask some action to be take place. And also output device also sometimes it may happen to display something, so the request will be transferred from IO device from service to processor. This is an interrupt. So the processor will provide a request by interrupt service routine. This is one of the register. From this register the interrupt values are stored. When the processor is free from the ISR, corresponding each instruction will go to the processor. After that the processor will execute those instruction. So these also have contents of PC, program counter, registers, information memory, everything will be needed. So when the in the ISR only, as I said, every instruction placed after that one by one in the instruction will be executed. Then the processor will restore those instruction. Then the interrupt program may be continued. This is known as interrupt. So this is the basic operation. Next class we will study about the bus structure. The big picture should be kept in mind here also, because as like functional unities, this big picture should be kept in mind. Memory, address register, data register, controlling like this. If you big picture is in the mind means you can easily draw the diagram. What are all the components present, and also from the diagram you can easily explain the operations which are being takes place. Thank you.